The purpose of this module is to talk about the importance of prototyping, the way to start building and testing your idea. What is a prototype? An initial representation of your idea that is more than spoken or written word and that can answer questions and/or elicit feedback. Various levels of materials and detail can be used. I'll discuss this and more in this episode. Second, it is impossible to build your invention in one sitting because there are many unknowns. Even though your idea looks good on paper, you won't know whether it works until you build and test. I will also discuss the motivation behind prototyping and guidelines to help bring your idea to life. Perhaps you have seen an advertisement for the Dyson vacuum cleaner. This famous series by Sir James Dyson took 5,127 prototypes and 15 years to get right. 5,000 prototypes in 15 years is a bit extreme, so let's talk about building a few quality prototypes within a year. Inventors never get it right the first time. Learn how to fail early, persevere, and move forward. Why do we prototype? First, representing an idea. You can't build your idea all at once. They say a picture is worth 1,000 words. Perhaps it can be said that a prototype is worth 1,000 pictures, or sketches, diagrams, etc. With the uncertain aspects of your invention, prototyping allows different members of your team to focus on the various parts. As you learn from the building and testing, you discover whether the individual components function as you intended them to. Then, you figure out how to integrate all the components to form a complete working prototype. Communication. Next, just because an idea works in your mind doesn't mean that the next person will also understand what you intended. If your prototype represents what you have in mind, the next person who interacts with it will be more likely to understand and correctly question and challenge the idea. Having a drawing is a first step. You may be able to get the ideas across. Having something built, that is working, with physical components, means you'll be more likely to be able to get your idea across to others who can give you feedback. Through prototyping, you can explore alternatives to making your idea real. There are myriad ways to solve a problem, and often it isn't clear at first which is the best one. Prototyping allows you to explore multiple avenues before investing a lot of time and money in one direction. What is a prototype? A prototype is an initial representation of your idea, focused on a particular aspect of the idea. Eventually, you will have a prototype that is the complete invention, but there are intermediate steps along the way. We will use the prototype triangle to break down different aspects of an invention. There are 3 broad questions that a prototype could answer relating to function, feel, and interaction. Each prototype should answer a question or set of questions. Don't get too ambitious for a given prototype. Since you may address multiple questions, the prototype might be located anywhere on this triangle. The final product, or completely integrated prototype, would be located in the middle of this triangle, as it shows that inventors have finalized the function, feel, and interaction of the invention in one prototype. For function, you could think of it as, how does it work? For feel, how does it look or feel, or how does it engage the senses? Interaction, how does a person interact with it or use it? In order to make this clear, I'm going to use an example. After you watch this segment, think about something that you know a lot about and/or are passionate about. This should be something that you can improve. It could be something around the house, like an appliance, or it could be a favorite electronics device, like a video game system or a cell phone. Since one of my hobbies is photography, I'm going to talk about improving the camera. With the camera, what questions might there be as we prototype? For function, we might prototype a new means of releasing the shutter. The shutter is the piece that allows or prevents light from hitting the sensor of the camera. For feel, we might prototype different materials for the grip. Depending on the age of the person using the camera, there might be more comfortable materials to use. For interaction, we might prototype the layout of the buttons on the camera and whether or not the user can easily understand how to operate it. Have you ever encountered a menu on a touchscreen that is confusing? Prototyping interaction is very important. For interaction prototypes, you can often use paper and pen to demonstrate this interaction. You would eventually need to test the interaction on a more realistic prototype, like a foam model of the camera. For any of the prototypes, the important part is to focus your efforts by answering a question or set of questions. And especially for questions related to feel and interaction, you want to get feedback from the beneficiaries for whom you are inventing. What is a prototype, and how do we measure it? In the module on project descriptions, I discuss product specifications. I will discuss it briefly here. Specifications describe what an invention does, but not how. The first two aspects of invention that will help you develop a specification are needs and attributes. A need is something that a user or beneficiary requires from the invention. An attribute is the characteristic that the invention has that will meet the need. A specification is the measurable technical quantity of the invention. Product specifications are the important key specifications that describe how the invention is useful to the intended beneficiaries and unique compared to existing solutions. For a camera, needs might include portable, takes quality photos for prints, and easy to repair. Let's see what the attributes and specifications are associated with it. The associated attributes that follow might be weight, sensor resolution, and disassemblability. And the associated specifications might be weight of 1 pound, resolution of 12 megapixels, and 10 minutes to disassemble. Who is it for, and how does it compare to what's out there? In order to discover and develop the possible needs and attributes, and thus the specifications, there are two equally important paths. First, who is it for and why is it useful for them? Second, how does the invention compare to what's already out there? That is, how is it unique? First, who is it for? You want to interact with the beneficiaries. These are the people for whom you are inventing. It could be end users or customers. You can consider anybody affected by the characteristics of the invention. While you cannot meet everyone's needs, you should definitely consider them. Other examples of beneficiaries might include the family members of a loved one whose life improves from a medical invention. There are different ways to interact with these beneficiaries and understand the needs and associated attributes. This could be direct, through surveys and interviews, or it could be indirect, through observation and research. Second, how does it compare? This can be called benchmarking. Learn about existing solutions through research. Find out how other companies and businesses solve the same or similar problems. You can benchmark what is out there by purchasing competing products and safely taking them apart to understand how these other inventions work. The uniqueness of your invention may take advantage of aspects that the competitors don't consider. Here is a way to understand your competition and find opportunities to make yourself distinguished. For the camera, consider the specifications of weight and resolution. On the XY plane, I have placed weight on the vertical axis and resolution on the horizontal axis. Let's say that there are two popular existing products. One is a high-res but heavy camera, and the other is a lightweight but low-res camera. An opportunity to make your invention unique to existing solutions might be a high-res and light camera. This is a simple example. Of course, there are other factors to consider, such as cost. Take a look at the problem you've identified and generate ideas about how your proposed invention solution would be unique to what is already out there. How do we prototype? Your time and resources are limited, so you should be wise about how much to invest in each prototype. As much as possible, prototypes should be quick and inexpensive compared to the resources you'll invest in the final integrated prototype. It is better to make mistakes and fail early on rather than discover the faults of an idea when it is very costly to change the design. There are two extremes on the spectrum of building and prototyping: do-it-yourself versus off-the-shelf. There are merits to both ends of your decision, and your decision will likely fall somewhere in between. Do you want to explore the idea completely from scratch, adopting a do-it-yourself approach? If so, it means that the question or concept you are exploring is vital to the core of your invention. Or can you buy an off-the-shelf existing solution that will save you time? For instance, if your invention is not about new motor designs, you shouldn't be making your own motors. Likely, your path will always fall somewhere in between the two extremes. As mentioned in the previous slide, with off-the-shelf, you can look at existing solutions or products that you can purchase and take apart in order to learn about previous approaches to the design and manufacturing of a particular product. Learning by analogy, whether from nature or existing inventions, can be useful as you develop a new idea. You can also repurpose and modify the off-the-shelf solutions to integrate into your prototype. Materials. Keep in mind what materials you will want to use. How important is it that the material you prototype with is the same as the final material? You'll be surprised at how much you can learn from paper, cardboard, and other household materials. Start there, if you can, before using materials that are higher quality and closer to the final prototype. In later modules, we'll talk about the engineering terms behind material attributes, but for now, consider some common attributes: durability, cost, weight, strength, machinability. Consider scale. Can you prototype at a smaller scale and make some initial conclusions about the feasibility of your idea? Or would building a large prototype for something smaller be useful? What are your plans for building and testing to actual scale? To conclude, I will show you examples of prototypes from some 2014 Lemelson MIT Invent teams. The St. Francis de Sales High School Invent team invented the automatic page turner. Shown on the left is an initial prototype made of acrylic and created by the laser cutter. The team investigated what material would be best for the mechanical structure of the linkage arms. Shown on the right is their final prototype 4 months later at the Lemelson MIT program's Eureka Fest, a multi-day celebration of invention located on MIT's campus where all invent teams attend to present and showcase their invention prototypes. The team decided to use a combination of materials for their final prototype. The Wausau West High School Invent team invented the semi-autonomous snow removal device. Shown left and above is an initial cardboard prototype that was a scale model so that the team could understand possible configurations for the complete system. Shown left and below is the team with their final prototype at Eureka Fest. Shown middle and right are screenshots from the Invent team's website where they documented the different stages of prototypes throughout their grant cycle. The Bridgewater-Raynham Regional High School Invent team invented the coffee pod recycler. Their primary means of prototyping was the 3D printer, and shown here are various prototypes throughout the months of development. The team had at least 5 other prototypes not shown in this Eureka Fest showcase photo. They learned a lot through exploring different variations on their recycler unit. As you explore your idea and test concepts, make sure that you document the work. Take photos and videos. Make diagrams and drawings. Then, when you need to communicate your work to others, you will have supporting materials. In conclusion, we talked about prototyping, or bringing ideas to life. Why do we prototype? First, we can't build it all at once. Next, it facilitates communication within your team. Finally, it helps you explore multiple solutions. What is a prototype? First, a prototype is an initial representation of your invention idea. At the beginning, you want to focus your prototypes on answering specific questions. Also, you want to focus on specifications and building and testing to see to what extent does your idea work. Figuring out the specifications requires interaction with beneficiaries and researching and benchmarking existing solutions. Finally, how do we prototype? We want to fail fast, early and often, and learn from our mistakes. You will always be deciding between two extremes of doing it yourself and buying off the shelf. Lastly, also think about materials and scale. This was produced by the Lemelson MIT program. The Lemelson MIT program celebrates outstanding inventors and inspires young people to pursue creative lives and careers through invention. It is funded by the Lemelson Foundation, based in Portland, Oregon, and administered by the School of Engineering at the Massachusetts Institute of Technology in Cambridge, Massachusetts. For more information on invent teams and JV invent teams, the youth invention grants from the Lemelson MIT program, visit lemelson.mit.edu.